Just like with arithmetic sequences, there was also an arithmetic series where you were adding your terms together. Well, there's a geometric series also where you're just adding your terms of a geometric sequence together. Here's an example of a geometric series. We're adding them together, so it's a series. You're multiplying by 3, so it's geometric. There was a formula for the sum of an arithmetic series. There's also formulas for the sum of geometric series. The two that are boxed in blue are the ones that are used most often. However, this one here is still sometimes used. For each one of these, a sub 1 is your first term. N, which is your exponent here, is your position. A sub n is your last term, and r is your ratio. Now just know that it does not work to have r being 1. Now if your r was 1, it is still technically geometric, but these formulas don't work because you'd end up dividing by 0. But if your r was 1, that means all the terms are the same. It's still technically geometric because you'd be adding a difference of 0. So let's take a look at this one. How many direct ancestors would a person have after 8 generations? So you each have a biological mother and father. Then they each had a biological mother and father, so that's a total of 4 grandparents that you have that are biological. Then 8 great-grandparents. Oh, we got a problem here. Okay, that's fixed. So now we have 16 after that, and then it would be 32, and so on, and so on, and so on, until we get to our 8th generation. First, second, third, fourth, fifth, sixth, seventh, and 8th. So there's a couple ways we could do this. We could use this formula here, because we know our first term, because that is 2. We also know our ratio. We're multiplying by 2 each time. And we're going for 8 generations. So that means our exponent is 8. So we could just type this into your calculator. If you're going to type this into your calculator, put the whole top in parentheses, hit divide, put the whole bottom in parentheses, and then you end up with 510 direct ancestors. Here's that summation notation again. So that means we're going to start by plugging in the bottom number 1 into our rule. So you get 2 to the 1 minus 1, which is 2 to the 0. 2 to the 0 is 1 times 3. So all I'm going to do is list out my first several terms. Then I'm going to plug in the next number up, which is 2. When I do that, I would get 2 to the first power times 3. Then I would plug in the next number up, which is 3. I get 2 to the second power, which is 4 times 3. And continue to do that until I plug in 12. Plugging in 12 would be my last term, so I'd have 3 times 2 to the 11th, and I could work that out. You notice, when I write this out, it ends up being geometric, because I'm multiplying by 2 each time. I have my first term, and I know the number of positions. I started out at 1, went all the way to 12, so I have 12 positions. So there's a couple ways you could do it. You could take your first term, which is 3, a sub n, your last term, the 6,144, r, which is your ratio of 2, and then you could put the whole top in parentheses, divide, and put the whole bottom in parentheses. Or you could have used this formula down here. You could have put in your first term, you could have put in r, and we got a typo. There we go, we got that fixed. With an n being 12, type in the whole top, type in the whole bottom, divide, or if you're doing it all in one line, put the whole top in parentheses, put the whole bottom in parentheses. So let's take a look at this problem here. We have our first term, we know that it's geometric, we have our last term, we have our ratio, and we're looking for the sum. So I'm going to use the formula that has all this information. I need my first term, I need my a sub n, I need R. So I'm not going to use this first one. I'm not going to use the second one because they don't have the A sub n. I'm going to use the bottom one because it has all the parts that I'm given. So I'll use that bottom formula, plugging in my first term, 7,776, plug in A sub n, which is 6, plug in R, which is negative 1/6, and plug R in on the bottom. Now all I have to do is put the whole top in parentheses, type it in, hit divide, put the whole bottom in parentheses, hit enter on my calculator, and I get 6,666. For this one here, I'm looking for the first term. I'm given my sum. And by the way, the subscript tells you what n is, so n is 8, and I'm given my ratio. But I need to find that first term. So I'm not going to use this first one. Yes, I have S sub n, I have n, I have r, but a sub 1 shows up in two spots. I'm going to use the second one where a sub 1 is basically factored out. It only shows up in one spot. It's going to make it easier to solve. I would not use the third option because that has an a sub n showing up, and we don't know a sub n. So I'll plug in my sum of 765, looking for my first term. My ratio I'll plug in on the bottom is 2. Plug in my ratio on the top for r, plug in my n being 8. So now all I have to do is solve this. So the bottom is negative 1. So I could multiply both sides by negative 1. The parentheses on the top multiply together to give you negative 255. So you could either multiply by both sides by negative 1 and then divide by the negative 255, or you can realize that a negative 255 over a negative 1 is positive 255. Then you can divide and you get your first term to be 3.